Welcome back. Today we're going to talk about matrices, and this is section 7.1. And a matrix, with the plural being matrices, is just a rectangular array of real numbers. Okay, so a lot of times what we're going to use this for is solving systems of equations, and so we're thinking about these in terms of these are the coefficient, and we're going to talk about coefficient matrices here in just a second. But first, let's talk about the order of matrices. The order of matrices are going to be given by two numbers, m and then by, or it looks like an x of times, m by n. So these would be the number of rows, and these would be the columns. And so, for example, if we have something where we have just one element, well, we ask ourselves how many rows there are, how many columns there are. Columns, of course, going up and down, rows going side to side. Well, in this case, there's one row and one column, okay, because it's just one element. In B, the number of rows is 1, but the number of columns would be 4 because I have 4 elements side by side. In C, I've got 2 rows and 2 columns. This one will be known as a square matrix. Square because the rows match the number of columns. So it's a square. In this one, we've got 3 rows and 2 columns. As we move forward into multiplication and things like that, we're going to notice that the order becomes more important. For today, we're just going to be looking at what is the order. So the order would be a 1 by 1 or a 5 by 7 or an 8 by 16, something like that. Okay? Now, this is where we get into using the coefficients and a system of equations to write a couple of different things. An augmented matrix and a coefficient matrix have a lot in common. I'm starting with this original system down here. Okay, and so this is my system of equations, xyz, and an x and a z. And as I'm writing this coefficient matrix, or the augmented matrix, I'm keeping in mind the coefficients of the variables. The augmented matrix is with answers. And you'll see what that means in just a minute. And this one is no answers. So the augmented matrix takes into account everything. And so what I can do is I'm going to take red here and I'm going to go in and make sure I know what all my coefficients are. There's a 1 here, -4, a 3. This would be -1. This would be 3. This would be -1. This would be 2x. Well, notice I don't have any y, so this is plus 0y because that coefficient is going to become important, minus 4z. Then in my matrix, all I need to do is write in all of my coefficients and then my answers. Here's what it looks like. Start with my first equation. This will be my first row. So I'll have 1, -4, plus 3, so I could just write 3. And then I'll do a dot, 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 and then after that comes my answer. That's my first row. Second row, -1, 3, -1, dot, 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 everything's in a line, -3. Third row, 2, 0. Now notice everything has to go in order. So all of my x's, all of my y's, all of my z's, -4 and 6. This is my augmented matrix, just with coefficients and then answers after my dot, dot, dot. My coefficient matrix is just the part without the answers. So this one's going to be easier to write because I'll just do 1, -4, 3, -1, 3, -1, and 2, 0, -4. No answers. That's my coefficient matrix. Okay, that's all there is to it, to writing these things out. Eventually this is going to help us solve equations or multiply by a scalar, something like that. So this is just a basic step in getting to the process where we can do matrix operations. Okay? In this one, we're going to write the augmented matrix. Here's my system. I want you to notice a couple of things. As we look through, I've got an x, a y, and a w in this one, and then I've got a y, a z, and a w. Okay, so I'm actually dealing with 4 variables. I've got x, I've got y, I've got z, and I've got w. And so I'm going to rewrite these matrices just to show you what we would need to do to make sure we keep track of everything. So my first equation, I'm going to rewrite it like this. X plus 3y plus 0z minus w equals 9. So notice now I have 4 spots. So each one I'm going to have 4 spots. So 0x for the second line, because I don't have an x, minus y plus 4z. And I'm crossing my z so I don't get confused with the 2, equals negative 2. X minus, so plus 0y, because there's no y, minus 5z minus 6w equals 0. And down here, 2x plus 4y minus 3z plus 0w equals 4. Notice I didn't change anything, I just added that spot in, so that 0z or that 0x. And that's going to allow me to really easily write this augmented matrix. And so when I drop down here, all I'm doing is taking the coefficients and the answers. So it's going to be 1, 3, 0, negative 1, dot, 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 9. 0, negative 1, 4, 2, dot, 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 negative 2, 1, 0, negative 5, negative 6, dot, 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 0, 2, 4, negative 3, 0, dot, 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 4. Here's my augmented matrix. Now maybe you could do that without writing it out with those zeros and those placeholders, and that's okay, that's fine. I want you to be able to get to that point, but I wanted to show you where this was coming from so that you wouldn't be blindsided by, hey, well, where did that 0 come from? Why is there a z all of a sudden? Because when we do the augmented matrix or the coefficient matrix, those letters get cut out, so it's important to keep everything in order and in line. Okay? Let's look at some matrix operations. This is moving into section 7.2, but this is going to be the first part of section 7.2, kind of an elementary going on. In A, when I'm doing matrix operations, and multiplying a matrix is fairly straightforward. 3A means 3 times each element. Okay, and so this is what's called a scalar multiplication. So we're going to up the scale 3 times. And so I can actually really do this without even too much heartache. So in my 3 by 3 matrix, which is what 3A is going to be because it doesn't change anything. Okay, and so I'm going to multiply 3 by 2, so this is 6. I'm going to multiply 3 by 2 of my second element, which is 6. I'm going to multiply 3 by 4, which is 12. I'm going to multiply negative 3 by 3, which is negative 9. 0 by 3, which is 0. 3 by negative 1, which is negative 3. 3 by 2, which is 6. 3 by 1, which is 3. 3 by 2, which is 6. Okay, that's all there is to it. You multiply each element by 3. So in B, when I'm doing a negative B, it's negative times each element. And so I'm just going to go straight across. Negative 2, 0, 0. This 1 becomes negative 1. Negative 4 becomes positive 4. 3 becomes negative 3. Negative 1 becomes 1 because it's times negative 1, so negative 3 and negative 2. Then this is just a combination of those two things. And so when I am subtracting B, it's the same as adding that negative B. So really, I'm just going to add these two together. When I add these two matrices, because they are the same order, I'm literally going to add this one plus this one. So I'm going to get 4. 6 plus 0 is 6. 12 plus 0 is 12. Negative 9 plus negative 1 is negative 10. 0 plus 4 is 4. Negative 3 plus negative 3 would be negative 6. 6 plus 1 would be 7. 3 plus negative 3 is 0. 6 plus negative 2 is 4. That is the way that you add matrices. Same order, boom, add the elements in the same corresponding spot. That's all there is to that part. Let's solve an equation with a couple of matrices. I'm given A and B. And I'm going to solve for x in the equation 3x plus a equals b. Well, look at what happens. If I rewrite this, I'm going to substitute in 3x. Well, what is a? A is this matrix. So 3x plus this matrix is equal to this matrix. I'm going to solve this like any other equation. And so all I need to do is get the x by itself. And so first, I'm going to subtract this matrix. Subtract 1, negative 2, 0, 3. When I subtract this matrix, negative 3 minus 1 would be negative 4. 4 minus negative 2 would be 6. 2 minus 0 is 2. 1 minus 3 is negative 2. So if I rewrite up here, 3x equals negative 4. 6, 2, negative 2. Well, think about it like this. 3 times something is equal to this matrix. Well, to solve for x, I need to divide by 3. So when I divide by 3, it's the same as dividing each element by 3. Dividing a matrix is dividing each element. Multiplying a matrix is multiplying each element. And so if I divide each element by 3, don't overcomplicate this. Because now it's negative 4 divided by 3. Done. 6 divided by 3. Done. 2 divided by 3. Done. And negative 2 divided by 3. Boom. There's my answer. I'm boxing that baby. Okay? Solve it in steps. Isolate your x using whatever means you need to, either adding, subtracting, then multiplying or dividing. And then from there, you're just finding your answer. Okay? That's all there is to it for today, guys. Thanks for watching, and we'll see you next time.